What's up, everybody? Today we are talking about factoring special cases. So this has to do, if you watched our last one, with our factoring, our special multiplication patterns that we saw when we multiply binomials. So what even is factoring? Factoring a polynomial is a fancy way of saying what I call undistribute. It is the reverse of the distributive property. So our goal is to take a polynomial that's written in standard form and rewrite it as a multiplication problem or in the factored form, right? Written as factor, something times something else. So let's go ahead and practice what it is that we're trying to reverse. So these are those two special cases that we talked about in the last lesson, but if you've forgotten or you didn't watch that one, and we're going to do an example here. So let's start by expanding. Here, I'm going to take x, multiply it by x multiply it by 4, so x squared plus 4x. Then I'm going to distribute negative 4 into the second binomial. So I'll have negative 4x minus 16. And then notice here that these middle terms are the same. So what we've got going on here is a positive 4x and a negative 4x. Those are actually going to zero out or cancel. And we'll be left with x squared minus 16. And that's our special fact or multiplication pattern, and it is called a difference of squares, or you may hear it called a difference of two squares. And it is aptly named, right, because it's the difference, a subtraction problem, of two perfect squares, in this case x squared and 16. All right, so what does this look like? Well, in its expanded form, that means written in standard form. Let's write along now here. Standard form. It's going to look like some a squared minus, and it's always going to be a minus sign, some b squared. And then in its factored form, written as that multiplication problem, it's always going to be one binomial times another binomial. One of them is going to be negative. One of them is going to be positive. Now, you could write it the positive one first and the negative one second because multiplication commutes. So it's okay if you write those in a different order. Later on, when we get a little bit more complicated, and we have difference of squares inception, which I'll tell you about later in probably Algebra 2, and is one of my favorite types of problems. I just really like having the minus sign one up front, but that's my personal preference. Most teachers are writing the plus before the minus, but as I said, when I first started my little ramble here, it doesn't matter because multiplication commutes. All right, so anyways, let's fill this in the rest of the way. So we'll have A as our leading term and B is our second term, right? So A minus B, A plus B. And those are the binomials that we multiply together to get this A squared minus B squared in the top. And so what's so cool about this is we know if we're stumbling upon a problem and we see that top A squared minus B squared, we know immediately we can rewrite it in that factored form. Me snapping probably is a little bit startling in the video, so I apologize. Big into sound effects, big into talking with my hands, which obviously also goes to waste in the video. But we know immediately that we can write it in that factored form, or vice versa. If I've got that factored form, I don't have to work through my double distribute and then combine my middle terms. I know immediately that I can rewrite it in that A squared minus B squared form, right? So this is about efficiency, right? Pattern recognition that's making our lives easier. Right? A lot of times students are like, oh, but I don't want to have to memorize this, but it makes your life so much easier, I promise. All right. Next, here we've got this one, the x minus 3 quantity squared. So I'm going to rewrite this as x minus 3 times itself so that we can go through our little double distributing here. So we know x gets multiplied by x and then by negative 3. So x squared minus 3x. And then we're going to do the same thing down here. We'll have minus 3 times x minus 3 times minus 3. So this will look like another minus 3x, and then it'll be plus 9. All right, so similar yet different from the last problem, we have the exact same middle terms here. So they don't have different signs, they have the same sign. And so they don't cancel, but we can combine them. So we'll have x squared minus 6x plus 9 as our answer here. And that is our second type of piece here. This is called a perfect square trinomial. So again, in the last video, we said it's because this is a perfect square, right? Just like 1, 4, 9, 16, and so on. Those are all perfect square numbers. This trinomial itself is a perfect square because it's the product of taking something, this x minus 3, and squaring it or multiplying it by itself. Pretty cool. All right, so let's fill in this side of our little graphic organizer here. A perfect square trinomial is going to look like the following. So if I have some a squared, and then if this plus or minus is what it sounds like. It could be positive, it could be negative. This is just more efficient than writing it twice. Our middle term, right, we always end up with two identical middle terms, which 2ab here. Oh, and I forgot to color code my a and my b. So that 2, right, is always going to be there because we always end up with that duplicate middle term. And then we're going to have plus b squared as our last term. So remember, what did this look like in that factored form before we went ahead and expanded it? Well, it was 1 binomial squared. Remember, we said earlier that this sign here, this is always positive. Okay, that just turned really messy, so let's try that again. Always. Ooh, like, can I turn this into Deathly Hallows? Let me get a little Harry Potter reference. Alright, always positive. And then this one here, it's always the same sign. I guess I can write in the, over here that this is always negative. The difference of squares. All right. Fill in my A, fill in my B. There you have it. So, like I said earlier, memorizing these will make your life so much easier because there are a lot of different factoring patterns that we're going to talk about. Some factoring problems are a little bit more complex, involve a little bit more work than others, and so we wouldn't want to do, say, 3 or 4 lines of work if we could have used this shortcut instead. Alright, so on the back we're going to factor each of these. So what we're doing is we're practicing rewriting these as the multiplication forms. And so what we need to do is these are all going to be either a difference of squares or a perfect square trinomial, and we need to determine which is which and go from there. So this first one is going to be a perfect square trinomial, and I'll walk you through how I knew that. So first things first is it's a trinomial. So that's good. Then I look and I need to figure out A. Well, if this is a perfect square trinomial, then this would be a perfect square. Well, it is a perfect square, so we'll say that my A here, my square root, if you will, the thing getting squared, is x. Then we need to look at the last term and see, is that a perfect square? And it is. Okay, so what did I square to get 16? Well, not 8. I was doubling. I squared 4. Okay, so now the last thing is we have to check and see if we have 2ab. So if I took 2 and I multiplied it by x and I multiplied it by 4, would I get the middle term that we have here, 8x? And absolutely, right? 2 times 4 is 8, 8x. So because all of that is true, we know this is a perfect square trinomial. And so that means it's going to factor as follows. It's going to be 1 binomial squared. And I always write it like this too, where I'm like filling in parts of a puzzle, right? Since I know it's a binomial square, I know that the sign in between is always going to be the same as this sign right here. Wow, that font was way bigger than I expected it to be. This sign right here is always going to be the same sign in our binomial. Okay, so if it was plus, it's going to be plus. And then we just insert a here. So if a is x, x goes here, and b goes here, or 4. So you end up with x plus 4 quantity squared. Now, the best part is these problems are all self-checking. So if you're like, oh, Kaylin, I don't know if this is okay, we can go back and check our work. So I'm not going to do it for all of these, but I want to show you how you would go about doing that. So I would rewrite my problem, x plus 4 squared. And we said that we could rewrite that as x plus 4 times itself. That's what it means to be squared. Now I'm going to double distribute. And hopefully you can see how this is coming together. I do think that checking your work not only gives you a little bit of that pat on the back so that you can feel reassured that you're doing everything correctly, but also it helps kind of reinforce the pattern, right? So that when you're working forwards and then backwards, you can really visualize where every part of, say, the product or every part of the factored form is coming together. So here we're going to end up with x squared plus 4x plus another 4x plus 16. And lo and behold, that does come out to be x squared plus 8x plus 16. So we are good to go. All right, next one only has 2 terms. So whenever I see that there's only 2 terms, I am thinking, could this be a difference of squares? So first thing is, I notice it's got the 2 terms there, so that's looking good. Then I check to see if the first term is a perfect square. So x squared is indeed a perfect square. So that means, again, the a here is x. Then I'm checking to see if 81 is a perfect square, and it is. So that means b here is 9, because 9 was my square to get 81. And then we want to make sure that we're taking the difference of these 2 squares. And so this is a difference of squares, which we know how to factor. Difference of squares is going to factor as one binomial times another binomial. One's going to have a minus sign, one's going to have a positive sign, and then we just plop in a and b. So a goes first, just like in the alphabet, b goes second. We end up with x minus 9, x plus 9. All right. Nope, can't do it. That's going to bug me. Oh, and I forgot that I don't have the stroke eraser. Alright, bear with me, fellas. I apologize. Alright, back in action. What's the point in having it make nice boxes if I'm going to mess it up? Alright, so next we see 3 terms, and we're hoping maybe this is a perfect square trinomial. So x squared, perfect square, 36, perfect square. Good. Alright, so A, here's going to be x, 36 is 6 squared, so that means B is 6. And then my middle term here is that 2AB, right? X times 6 times 2. So we are good to go. This is a perfect square trinomial. Alright, so how that factors is 1 binomial squared. We're going to take that first sign here, and that's going to be our sign in our binomial. Then we plop in A, plop in B. We are good to go here. X minus 6 quantity squared. Alright, so go ahead and pause the video, y'all, and do 4, 5. And if you're feeling up for a little challenge, 6 here. 5 and 45 are not perfect squares, but they have a factor in common. One might even say a great factor. So see if you can factor out a GCF and uncover hiding difference of squares. All right, so go ahead and work through 4, 5, and 6, and then come back and check your work with me. All right, let's go over these here. So 4x squared minus 25 is in fact a difference of squares. So it's going to factor, it has 2x minus 5, 2x plus 5, and of course you could put 2x plus 5 times 2x minus 5. Multiplication commutes. Alright, 5 was in fact a perfect square trinomial, and we ended up with x minus 3 quantity squared. You guys are doing a great job. Alright, this last one, trying to stump you with that GCF, but you're no match for my tricks here. You saw that they had 5 in common, so you factor that out to the beginning and got x squared minus 9. X squared being a perfect square, 9 being a perfect square, you knew that you could factor this as a difference of squares. So you had x minus 3 and x plus 3. All right, great job factoring, everyone. Factoring is so fundamental to algebra, and I know that for a lot of students, this was the hardest part of algebra for them, and it doesn't go away, right? It's here in Algebra 1, it's going to come back in Algebra 2, it's still going to be there in pre-calc. If you take geometry in between Algebra 1 and Algebra 2, hopefully you're seeing it some in geometry as well. It is a skill super foundational to everything that we're doing in algebra moving forward, and I don't say that to scare you, but instead to say we're going to have so much practice available and time to improve on our hands. So if you find it frustrating at first, I totally understand. It was not my favorite either. And so that my own personal struggles with factoring have really affected how I go about teaching my factoring to my students and making sure that I try to find a balance between memorizing tips and tricks like difference of squares and perfect square trinomial, but also a really fundamental understanding of how multiplying and factoring work together as inverses here. So I hope you're having a great day, and I'll see you later. Bye.